So the atomic mass, which is on the periodic table, right, is the weighted average of all the naturally occurring isotopes of that element. So here's your formula for average atomic mass. A stands for abundance. Okay, this is going to be the percent abundance. All right, and it's going to be we only use naturally occurring isotopes in this formula. M is going to be the mass of the isotope or the isotopic mass. All right, and you're going to have as many terms. Each one of these things in parentheses is called a term. You'll have as many of those as you have isotopes. So, for example, if we look at some isotopic data, okay, if we look at argon, argon has 3 isotopes. You would have 3 of those terms, 3 of those things in parentheses. Chlorine only has 2, so you're only going to have 2 terms, okay? So this is data that you have to be given or you have to look it up. So if we take something like this, neon, that has 3 isotopes, okay, we want to calculate the average atomic mass, we would first write our formula. So average atomic mass is equal to the percent abundance, okay, divided by 100 times the mass of the first isotope plus percent abundance divided by 100% times the mass of the second isotope Okay, since there's 3 isotopes, we need 3 terms. Okay, so since we're just writing our formula, we can just put dot, 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 and then we just basically going to plug our numbers in. So this is going to be equal to 90.48% divided by 100%. Okay, our percents are going to cancel out. Times 19.992 atomic mass units. Okay, plus our second percentage, so it's 0.27% divided by 100 times the mass of the second isotope, 20.9994 AMUs. Okay, all that in parentheses. Then plus, since we have 3 isotopes, we got to have 3 terms. So plus, our percentage is 9.25% divided by 100% times the mass of the third isotope, 21.991 AMUs. Okay, so all we're going to do is we're going to solve for each little thing in the parentheses, then add those 3 numbers together. Okay, and we're going to get the average atomic mass of neon, which should match the same thing that's on the periodic table.